In this video, we're looking at parallel lines, which are lines that have exactly the same gradient as each other. Before we start, I just want to recap the idea of y equals mx plus c, which, if you remember, is the main format we use for line equations, and the m in front of the x represents the gradient of the line. So for parallel lines, which all have the same gradient, they'll all have the same value of m. For example, if we look at the equations for these three lines that we've drawn, m is 2 for all of them, and this is how we know that they're all parallel, which is why they're all going at the same angle, and they won't ever touch each other. Now, one thing that you need to watch out for is that the equations that you're given are actually in the form of y equals mx plus c. For example, if we had the equation 3y equals 2x minus 9, the number in front of the x is a 2, so you might think at first that the gradient is 2 and is parallel to our other lines. However, this equation isn't actually in the form of y equals mx plus c. Because we shouldn't have any numbers in front of our y to get into the right form. We need to divide everything by 3 to get the y on the left by itself, and that would give us y equals 2/3 of x minus 3. So the gradient of this line is actually 2/3, not 2. And just to show you this visually, if we plotted it on our graph, it would look like this. So you can see quite clearly that is not parallel to our other lines in exams. One of the common questions you'll get in this topic is something like this. Line A has the equation y equals 3x minus 4. Line B is parallel to line A and passes through the point 1, 4. Find the equation of line B. So first of all, the main thing to remember with questions like this is that in order to find the equation of any line, in this case line B, we always need to know two things. One is the gradient of that line, and the other is a set of coordinates that the line passes through. In this case, we already know the coordinates because they tell us in the question that it passes through the point 1, 4. So all we need now is the gradient of the line. They don't tell us the gradient directly, but they do tell us that line B is parallel to line A, which means that both lines have the same gradient. So if we can find the gradient of line A, that will also be the gradient of line B. If we take a closer look at the equation of line A, we can see that it's already in the form of y equals mx plus c. So the gradient, which remember is represented by the letter m, must be 3. This means that line B, which remember is parallel to it, must also have a gradient of 3. And now that we know both the gradient and a set of coordinates that the line passes through, we can finally work out the equation of the line. We've already covered how to find the equation of a line in other videos, but to quickly recap, once you have the gradient and a set of coordinates, you plug those values into a y equals mx plus c equation to find c. So here that would give us 4 equals 3 times 1 plus c, which simplifies to 4 equals 3 plus c, or 1 equals c. And now that we know both m and c, we just plug them both into a new y equals mx plus c equation to get y equals 3x plus 1 as our final equation for line B. So basically the take-home message here is that parallel lines have exactly the same gradient. So if they give you the gradient of one line, you also know the gradient of all of its parallel lines. Also, because parallel lines all have the same gradient, they'll always be the same distance apart, and they won't ever touch each other anyway. That's everything for parallel lines. So thanks for watching, and we'll see you again soon.